Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
We know that the internal energy of a system is sum of its kinetic along with potential energy of all the particles that compose the system. The internal energy is the state function. The internal energy value depends on the state of the system. So we are given with the mass of billiard ball. So the mass is equal to 0.17 kilograms, and the initial will be 4.5 meters per second, and the collision speed, wait a minute, and the collision speed will be 3.8 meters per second. So the expression for kinetic energy is equal to half mv square. The final energy of the system E2 is equal to 0. The initial energy of the system, that is E1, is equal to kinetic energy, which is also equal to half mv square. Substituting in the values, we have half multiplied by 0.17, and velocity is 4.5 square. We have E1 equals to 1.72 kilogram meter square second square, and E1 is equal to 1.72 joules. From that, we can find the difference between energy state, that is E2 minus E1, which gives us 0 minus 1.72, gives us the difference of energy as negative 1.72 joules. From the given condition, the billiard ball loses some of its energy as a heat. Using Ke equals half mv square, we can determine the kinetic energy as 1.72 joules. The ball involved in collision. Then we have mass and velocity. Again, the kinetic energy of the system can be determined as half mv square. This is the second kinetic energy, which turns out to be 1.22 joules. There are two difference between energy levels, which can be determined by formula K2 minus K1, that is kinetic energy of second system minus the kinetic energy of the first system, which gives us the loss of energy as heat is equal to negative 0.5 joules. From the first law of thermodynamics, work done is equal to delta E minus heat, which is minus 1.72 joules minus 0.5 joules. It gives us the work done as negative 1.2 joules.